Hello guys, welcome to Hora Tech. Today we are going to solve the LeetCode problem number 134 and called as gas station, and this is of type medium and it's asked in most of the companies, especially the product based companies. So as it mentioned, it's a medium, but it's kind of a problem statement is quite confusing, but the solution is very simple. Okay, so if you guys able to understand the problem statement clearly, then it's very easy to solve. Okay, so what I did is, in order to make you guys to understand clearly, I represented this inputs in a graphical representation as shown here, so that once we walk through the problem statement, I will show like how we can solve it and what is the way and to understand this problem. Okay, so let's dive into the problem statement. What it says: there are n gas stations along a circular route. Okay, they are given a route, circular route, and in the route there are n stations where the amount of gas at the particular station is gas I. And so if you are at the in the route, if you are at the ith station and the gas available in the ith station is gas of I. Okay, and you have a car with an unlimited gas tank. So basically they will assume that you have a car and it can store an infinite gas in it. Okay, and it costs you say like of I to travel from I station to its next station. Okay, and it consumes cost of I to travel from I to I plus 1, means to travel from one station to another station it costs to I plus, basically cost of I. Okay, and you begin the journey with an empty tank at one of the gas stations. So whenever you start your journey, right, basically you start with the empty tank. There won't be any gas in your car. Cool. Now given two integer arrays, right, and gas and cost, return the starting gas stations index if you can travel around the circuit once in the clockwise direction, otherwise return -1. So what it says is we need to find the station, especially they mention it here, it as an index. We can say it as a station, and that is index of the station, and where that can help us to make one whole path. Okay, in the route. If not, right, if we are not able to make a path with any of the stations, then we can return a -1. Okay, and also they mention if there is a solution exists, guaranteed to be it is a unique. They said it's only one station which helps us to make a circular path, and we need to find that station. Got it? So now let's dive into the problem statement, example 1. So I'm going to copy this here and put it over here. Okay, now once I'm here, let me walk you through this graph, why I did it and how I represented everything. Okay, cool. So gas they given as 1 2 3 4 5. I represented in the nodes here 1 2 3 4 and 5. Okay, these are the gas stations I represented as a node, and the distance are the, maybe I call it as a distance only because it make us to understand very easily instead of a cost. Okay, so I represented distance as like route between the two nodes, that is 3 is represented between 1 and 2, right, and 4 is represented between 2 and 3. Okay, and 5 is represented between 3 and 4. 1 is represented between 4 and 5. 2 is represented between 5 and 1, starting to the same node. Cool, this is how I represent it. So now let's understand how to find the index, means the particular station where we can start and be able to make the path, circular path. Okay, so once we start, say we bring our car at this node, okay, at this station, and we know that only 1 kg of gas is available, and we will fill that 1 kg of gas in our car. And how much distance we need to travel? We need to travel 3 kilometers, right? So 1 kg, say our car gives the 1 kilometer right? 1 kilometer it gives 1 kilometer it gives of mileage by consuming 1 kg of gas, right? If this is a condition, right? So can we travel with 1 kg 3 kilometers? Is it possible? No, right? So what we can say is this index is not a this index is not a solution. So what we do, we should move to the next index. Cool, that is 2. So so what is the difference here? Actually this is -2, correct? So can we travel from 2 to 3 with a gas of 2 kg? No, because 4 is the kilometers and 2 kg of the gas is available. We can't travel. We need a 4 kg of gas to travel 4 kilometer and to reach the third station. So what is the difference again available here? Let me rewrite this. So 2. So now in order to travel, so the second index is also not possible. So now let's check with the index at a third, right? And what is the gas available if you bring a car at this station, and if you fill with the 3 kg of gas, can we travel to the fourth with of distance 5 kilometers? No, still not possible. So let's note down the value, diff value between the gas and the distance. That is 3, right? Oh sorry, that is 2. Cool. Now let's move to the next index. Once we move to the fourth index, and if we see can we travel to the fifth station with a gas of 4 kg, and what is the distance? 1 kilometer. Yes, it's possible. Why? Because we have enough gas, right? And distance is very less. We can easily reach to the fifth station. And what is the gas available at the fifth station? It is 5. So what is the gas left in the previous journey? That is, we left with 3. So what is the diff here? First of all, I forgot to calculate the diff here. 4 minus 1, that is going to be 3, right? And it is added up to the next station. So again we should fill our car with the current gas station's value, right? Once we add it up, it is the total gas available in our car is 8. Can we travel to the next node and of kilometer 2? Yes, we can. And how much gas we want to consume? If you say here 8 minus 2 is 6, so we have a 6. So we are going, once we move to the next station, we are going to add with the next station's gas. So 6 plus 1, it becomes 7. So I'm going to erase the previous calculation. No, let not erase. I'll write on top of the previous value. So now 6 plus 1 become 7. That is positive value. Now can we travel to the second station? Check it. Let's check it, right? How much distance we need to travel? 3, right? Now what is the gas available? 7. Yes, we can easily travel. And how much gas is left over once we reach to the next station? That is plus 4, right? 7 minus 3, 4. We left with the plus 4 as a gas, right? Can we travel to the third station and of distance 4 kilometers? Yes, we have a gas of 4 exactly, and we have a 4 kilometers distance, right? And what is the gas left in the after the journey? It is 0. And now we fill with a 3 kg of gas. Can we travel, right? Can we travel? Sorry, wait a second. So we were having 4 here, right? 4 plus it becomes 6, right? Here we did a mistake. This one becomes 6. 6 plus this after summing. Wait a second. This is just a confusion, guys. Okay. This is of plus 2. Okay. What is the leftover gas after journey from 1 to 2? That is 4. So total left is like 6, right? 6 minus 4, so another 2 is left. So now that 2 is going to add it up here, right? So 3 plus 2 in the next station, once we reach it, 3 kg of gas is available, and 2 is already left over from the previous journey, right? 5 it become. So 5, can we travel to the next station? Yes, we can travel, because like there is only 5 kilometers and gas left is like a 5 kg, so we can reach to the next station, and that is the starting index which we started here, right? So this is our result. Fourth is our result. So we made a one circular path, right? So that index where we started, we have to return. That is going to be our final result. Got it? So let's understand another example which is given here. 2 3 and 3 4. Let me copy over here. Okay, so I drawn here already. Okay, cool. So now 2 3 4 as represented something like that, right? Gas are represented as node, and cost are represented as the path between the nodes, right? 2 3 and 4, 2 3 and 4, 3 4 3, right? Can we travel from station 2 to 3? Let's check it out. So what is the gas available here at this station? 2. And what is the distance we need to travel? What is the diff we got? -1. We can't travel, so this is not our starting station. Can we travel from third station to fourth? And sorry, this is a node, right? Can we travel between third to fourth? What is the gas available here? 3. But what is the distance we need to travel? 4. So it's not possible, so again -1, right? So let's check, can we travel from this particular station, right? So when we start from the third station and gas available is 4, and distance we need to travel is 3 kilometers to reach to the second station, so we can travel, right? +1, right? 1 is added, and so 1 plus 1, it added to the next station, right? So 1 plus 2 become 3. Can we travel to the next station? Yes. Once we travel, what is the gas left? 0, right? We can travel 3 plus 3, so it become 3. Can we travel to the next station? With currently it is available 3. Can we reach again to the starting point? No. So we are not able to make a complete loop, right? And if you are not able to make a loop, we have to return -1, right? Cool. Hope you guys able to understand the problem, right? So now moving on, there is another corner case where we can easily find whether is it able to make a complete loop or not. How can we make it? It's very simple. We need to add the value of all the gas stations, right? And add a value of all the cost available. If cost available is greater than, right, if it is greater than the gas available, right, we can't make it, because how much gas we require to travel the distance, right? It should be same or it should be greater. It should not be less. If it is less than, if distance is greater than the gas available, we can't travel, right? So in that case we can return -1. So let's write it up how we are going to solve it. Basically we need to sum up, right? So to sum, I'm going to take a 2 variable. One is sum of distance, that is the cost, I can say it 0, and sum of gas, okay, that is also 0, and we need a result index, right? I can say the result index, that is basically an gas station index. Cool. Now iterate through the array for I in gas size is 0 until gas dot size. Cool. And we need to sum up, right? So let's say sum of distance is equal to, so we will keep adding it, gas of I, okay, and sum of sorry, this is distance, that is cost, right? Gas of, hope you guys know like why I named it as a distance instead of a cost, because it's very easy to understand. Cost is somewhat confusing. Okay. Now gas, right? Gas of I. So now we need to check, as I said, right, we need to check the diff. If it is negative value, right, what we should do, we should reset. Basically we start, instead of considering this index, we are going to bring our car here and fill from this station and check whether can we move to the next station, right? If it is negative, what we should do, we should reset. If if diff, right, basically what is that, another variable we need to take it, that is as diff is equal to 0. So let's say diff is equal to gas of I minus cost of I. Cool. If this diff is less than 0, what we should do, we should reset. Diff becomes 0 and the result index is equal to, we move to the next index, right? When we are at here and we found it is negative, we have to move to the next station to check whether the next station are we able to travel and make a circuit. Okay, once we reset, this is the result index stored. Cool. And now, as I said in the last, we need to do the sum check. If you return the result like this, return if sum of gas is less than sum of distance, right? If it is less than, we should return -1, else we should return result index. Okay, now let's run this program and see if it works. Okay, there is a issue that is saying like expected at this cases, right? So maybe we forgot to do something. Oh yeah, when we come back, when we move to the next stations, right, as I said, we should add it, correct? We should add the previous gas left over from the previous journey to the current station gas. So then only we are able to move and find the path, are we able to make a circuit. Okay, so this is a mistake. Let's run it again. Cool. This works. So this is about the gas station problem, guys. Thank you so much for watching. Please don't forget to like and subscribe. See you in the next video. Thank you. Bye bye.